Hello students. Next we will look at what are the actuators that we are having, starting with the hydraulic actuators. To understand the hydraulic system, look at this particular diagram. Here we are having a liquid which is incompressible. Incompressible. That means it cannot be compressed to a lower volume. It cannot be compressed to a lower volume. Just like oil. Even water is incompressible, but for higher viscosity, we go for oil. So it is incompressible. That means you cannot compress it. So if there is a particular pressure being applied in this particular fluid, if there is a pressure in this fluid, that pressure will be experienced in every inch of where this liquid is being kept. Every inch of that space or volume boundary where this oil is present will feel the same pressure, not different in any place. It is same everywhere. The same pressure will be felt everywhere. So that pressure is constant in every inch of the boundary. Now, using the Pascal's law, which says that the pressure in an enclosed fluid is uniform in all the direction. That means in all the place in the boundary it is uniform. There is no change. Then if you are looking at the pressure, what is pressure? Pressure is force per unit area. Okay, pressure is force per unit area. So if you are going to look at what is the force being experienced, it is pressure into area. So here if you want to look at what is the force, that is pressure into area. So now when we are having pressure, so suppose we are having pressure equal everywhere and the pressure is equal, and that is given by the Pascal's law. What happens is, suppose if we are having a pressure of a force of F1 applied in an area of A1 like we see here, and we have force F2, which is this one, having an area of contact with that liquid to be A2, the Pascal's law says that the pressure should be same. Now if the pressure is going to be same, what we can see from here is that F1, if we are having a force F1 applied at this side, then that F1 divided by A1 multiplied with A2 is going to be the force F2 that is felt here. So whatever is the original force that we are having here, that is multiplied by a factor of A2 by A1. So let me write that. F1 multiplied with the factor of A2 by A1 is going to give me F2. So if I increase A2 and reduce A1, if I increase A2 and reduce A1, that much more it will be force F1 will be multiplied and we will get the value of F2. So in a way, this cylinder basically multiplies the force. And that is what is written here. Please make sure that this is F2 into A1. Okay. So originally if you would rewrite this equation, it would be F2 by A2 is equal to F1 by A1. That actually can directly give you this, and that is what we have written here. Okay, so if I am going to increase A2 and reduce the value of A1, then I will have a multiplication of whatever is the force that is being applied here, and that is the reason or how the actuator hydraulic actuator actually works. It multiplies the force given in one side so that we experience a huge force in the other side. So here it might be just a simple person pushing it, and here a heavy load is being lifted up. Now suppose this area is let's say 1 meter square. Which one? This area, this circular area of this piston surface area is suppose 1 meter square, and the other one here is having a very low radius, and because of which its area is 0.01 meter square. Then this will give us, so this is F2, so this is going to give us 100 times, sorry, this is F1, and it is going to give me 100 times F1. That means F2 is going to be 100 times F1, 100 times of force. So you can imagine that if one person is standing here, 100 people can stand on that and it will be lifted up. Or 50 people can stand, or 90 people can stand, and still it will be lifted up. So that is how the hydraulic actuators work. Now people always feel that okay, that means someone has to apply a force here. No, the only thing that we have to do is we have to increase the pressure inside this liquid. Increase the pressure inside this liquid, automatically the force will be multiplied. If you increase the pressure of the liquid, automatically the force will be multiplied here. So one way of increasing the pressure in this liquid is by applying a force here. There can be another way, that is, suppose if you are having a tank, you are trying to pump in oil from here, then everywhere the pressure will be more. The pressure experienced everywhere will be more. So one way is by applying a force in the piston, the other way is by pushing the liquid inside, and that is what is happening in the case of hydraulic actuators. The system is which is given here. Okay, let me draw this one is okay. So this is the system. Now here is where you want to lift the weight, or you want to apply this arm. Okay, this is where the movement is going to occur with the help of a piston, and the piston can be moved up or down by either filling liquid or the hydraulic fluid in this chamber, or by filling it in this chamber. So if it is filled in this chamber, the piston will move up, at the same time this one will move out, and if it is filled in here, the piston will move down, whereas the excess oil in this side of the piston will basically move out of the chamber. So by putting the amount of oil, when I say by putting oil, it means that I am basically putting pressurized oil. By putting pressurized oil, compressed fluid, we can move the piston up or down. So how do we do it? How do we do it? So there is a fluid tank. From the fluid tank, the fluid is basically taken up. How? With the help of a hydraulic pump. So a hydraulic pump might be just like a pump that is used in your house to draw water from the well. Okay, it is a similar kind of pump, not the same but similar kind of pump. That pump will be used to basically pull the fluid from the fluid tank, and there is a filter in between that will basically take care that no dust or soil particles or solid particles are waste are basically pulled from this tank to the system. So once the hydraulic pump is pushing the liquid through it, the pressure of the oil that is coming from this side, not from this side, because this side is just drawing it. So from at this side, how much pressure is going to be felt is going to be decided by how much power the hydraulic pump is used to pump it. So that pressure can be regulated by changing the volume which is getting pumped. So if the hydraulic pump is basically rotating very fast, if the hydraulic pump is rotating very fast, then more volume will be put inside. If it is moving slowly, then less volume will be put inside. So based on that, how much volume is going to come through the hydraulic pump, the pressure is going to be decided. And here you have a pressure regulator which can help you to regulate how much pressure is coming here, how much pressure is coming here, by basically releasing some of the oil back into the original fluid tank. So in a way, the pressure regulator basically controls the pressure by changing how much volume is getting pushed from this side to this side. Okay, so let me again clean this diagram. Okay, so once we have a pressure of a whatever value we want coming here, now we have a control valve. The control valve is basically, what is valve? A valve is going to give you, which direction the oil is going to flow. So if you want the oil to flow through this pipe to the cylinder top position, that is through inlet A, if you want the oil to pour in, then you will control the valve for that. So if you want to move the piston down, you will place the control valve in such a way that through inlet A, the pressurized oil is going inside. Similarly, if you don't want that and you want instead the piston to move up, then you will basically stop this inlet, that means inlet A, and you will turn the control valve in such a way that the oil is basically directed to inlet B. And this side of the chamber will fill up and the piston will basically start moving up. So for moving up or down, you respectively open inlet A or B based on the control valve. There is a third position of the control valve when you want this position to be held on. That means you don't want this to lose this position. You have lifted it up to here and you want to maintain that position. You don't want it to come down or go up for some time. If you want to maintain that position, then what is one way? One way you might think that, okay, I will switch off the hydraulic pump. No, I cannot do that, because the hydraulic pump, if it gets switched off, then the pressure is gone, because otherwise we'll have to basically stop it here. So what we do is, with the help of control valve, we send that excess oil that is getting pumped back to the fluid tank through the third outlet, which I will name it as C. So the control valve will either send the oil here to inlet A, or it will send it to B, or if it has to hold on to that position, then it will send it to C, through which it will go back to the fluid tank. So that's how a basic hydraulic unit works, and you can basically move, or you can move any heavy load, or you can lift any load by attaching it to this one. The same principle is used even in the JCB arm. So you might have seen the JCB is having an arm, and that is used to do earthworks. So how it does with the help of hydraulic units like this. And this movement and the piston and all, you can see this is not a very big piston, it's a very small piston. It may have a circular this thing of 0.1 meters, only 0.1 meter square. It may have a diameter, but as I said, the pressure is going to be decided here by the hydraulic pump. The hydraulic pump might be trying to push too much of volume, and that will create a lot of pressure here. Okay, now in your notes, so I have written all of this. You can read it now. Next, I have drawn even this particular diagram for explanation. There is no need for you to study this, because it's one and the same thing. It's just that this is showing how the things will be done with the help of a controller and with the help of a sensor. That you need not study now, so no need for you to study this diagram. This one will be enough. This diagram will be enough. Next, what are generally there? So the hydraulic piston will be basically connected to a linear or a rotary cylinder. Okay, then we will have a hydraulic pump, which is a high pressure pump which provides the high pressure fluid to the system. And what runs that pump is basically an electric motor. So when I say it's a hydraulic pump, the hydraulic pump will have an electric motor which is basically turning inside to basically suck up the oil, or to take the oil and push it through. So that you will understand now. Cooling system is there because a lot of heat is there, so you should have a cooling system, just like we have in the case of cars. There is a cooling system where we use radiators and cooling fans, just like that we use in here also. Then there is a reservoir where we keep the excess oil. Okay, and then we are having valves. Okay, and then sensors and all these are there in the diagram. Now let us look at each of these components one by one. First is the hydraulic pump. So how does a hydraulic pump work? A hydraulic pump basically tries to take in oil from one inlet and push it out of the other inlet. So how does it move? To move this, you may have a electric motor. Okay, that we will see in detail. The hydraulic pumps are generally characterized by its flow rate capacity, that how much capacity, how much flow rate it can maintain, how much power is consumed, that means how much electrical power is consumed to run the motor, so that the hydraulic pump works. Drive speed, that means how much, with how much speed it can work. And finally, the most important one, what is the pressure delivered at the outlet and the efficiency of the pump. Okay, efficiency of the pump. Generally, it is not 100% efficient. It is not 100% efficient. Okay, and there are basically two types of pumps. One is called as a centrifugal pump, and another one is called as a reciprocating pump. What is a centrifugal pump? What is a centrifugal pump? A centrifugal pump, let me show you by example. This is a centrifugal pump and this is a reciprocating pump. These are the two kinds of pump that we discussed here, isn't it? The centrifugal pump is also called as the non-positive displacement pump, and the second is a reciprocating pump or positive displacement pump. So what happens here? To understand that, look at the centrifugal principle. So here you have this fine fan kind of structure which is rotating at high speed, and there is no gap here. It is completely just like sealed. So every time oil is present in this inlet pipe, every time it is present, it's not pumped. Why? Because basically the centrifugal pump is basically pulling it up. Okay, so it is not pumped from this direction, but it is getting pulled. How is it getting pulled? Every time when this is rotating, a vacuum is created here, because of which the oil gets pushed inside and it fills this chamber. And once this chamber is filled and this one again rotates, then here a vacuum is generated. And that vacuum is again getting filled by whatever the oil is coming there from down. So with each rotation, you will have these chambers getting filled up and the oil getting sucked in, and finally whatever oil is getting sucked up and filled in this much section is basically pushed out by the centrifugal action when it reaches here. So from here it is through the help of centrifugal action. What is the meaning of centrifugal action? When you rotate something, the force will basically, when you try to rotate something from the center, the force will always be tangential to it. That is the centrifugal force. So that centrifugal force is basically used to push the oil outside. Once its oil has gone outside, it becomes a vacuum here. And that vacuum again comes here, and again the oil gets filled. So as this is rotating, you are having this centrifugal pump pumping oil. Whereas what is happening in a reciprocating pump, what is happening in a reciprocating pump, or also called as a positive plunger pump, is you are having a piston arrangement which is connected to a motor. Now this can be connected to a motor, or it may be even connected to a diesel engine or petrol engine. Whatever be the case, if it is connected to a motor, it will basically rotate. As this is rotating, the piston will basically come down or move up. So with each half stroke, the cylinder will basically, the piston will move down, and with the next half stroke it will move up. Now when it is moving down, this inlet valve will open, and because of the vacuum that is created in this chamber, because the piston is moving down, because of the vacuum that is created here, the oil will be pushed from this inlet and it will move inside. At that time the outlet valve will be closed, so no oil will go outside. And then what will happen, if you want this one to move outside, then in the second half stroke the piston will move up, and whatever oil that has been collected here, that will be pushed out through this outlet by opening the outlet valve and closing the inlet valve. So when you close the inlet valve, this one will get sealed, and only this one will get sealed, and only this will open, and because of which the oil will basically move out of the outlet valve. And that is how a reciprocating pump works. And why we call it as a positive displacement pump or a positive plunger pump is because the action is basically developing a vacuum here. Okay, and that is what is written in this explanation. You can read it. Now, which are the different types of pumps? Let us look at some of the pumps. Okay, one of the important ones is, just hold on, okay, is gear pumps. Gear pumps are the best example of simple positive displacement pump, not the centrifugal pump. It is the positive displacement pump, or the second kind that we have studied here, which is the reciprocating pump. Okay, so the gear pumps are of two types: external gear lobe pump and internal gear pump. What is happening that, for understanding that, you have to look at the structure. So this is the external gear pump, this is the lobe pump, and this is the internal gear pump. What is happening is, we are having this spur gear, and both these spur gear are rotating in the opposite direction. Okay, both these are rotating in the opposite direction. There is almost no gap in between this, so there is no oil that is getting pushed from here to here. Don't think that because this is rotating like this, you are having the the oil pushing through within this gap. No, that is not what is happening. What is happening is, as this is rotating, as you can see the direction of rotation, as it is rotating in this direction, you see these small chambers here. These chambers are slowly collecting the oil from here, and it is rotating, and all the way it is traveling here, and here it is slowly released out, and that oil is basically what is taken here. So every time, whenever we are having this one rotating, and whenever we are having the oil coming here, a vacuum will be generated here, because of which more and more fluid is getting pumped in, or sucked in. Whatever is taking place here, the same thing is happening here. Here it is rotating in opposite direction, and here it is filling up the oils and slowly taking it on top and leaving it at this side of the chamber. So there is no oil leakage between these two. There is no oil leakage between this chamber and this chamber. Clear? The same concept is somewhat used in the lobe pump, wherein you are not having this spur gear, but you are having this lobe system, where again the gap between these two is almost zero. It is zero only. So here what happens is, as this is rotating in the opposite direction, so this is rotating in this direction, this is rotating in this direction. So this much chamber is filled with oil, and that oil will be released once it turns and brings it here. Similarly, as this is turning, it will take this much chunk of oil, it will rotate it, and it will bring it and leave it at the outlet. So that is why, as you can see, the arrow mark shows exactly where the oil is getting pushed through. In a way, it looks like spur gear, but this has more volume displacement, the lobe gear. Not lobe gear, lobe pump. So this is called as the external gear pump, this one, first one, and the lobe pump. The third one is this internal gear pump, wherein you are having this C section, or what is called as the crescent seal. And this crescent seal is of such form that it is collecting the fluid and it is rotating, and it is throwing the fluid out through this. So this crescent shape thing that you see here, this crescent shaped one, that basically divides and tries to keep it tries to maintain the vacuum, so that again and again it's sucked up, and this oil within this particular chamber is sealed because of this crescent, and after it reaches at the fluid output, then only this is released. These are basically the hydraulic actuators. In the next class, we will see the control valves that are used in the hydraulic actuators. Thank you.